Hey guys, welcome to question MM401 of the Maths Methods Fortify study guide. So in this question we've got a local hardware store is conducting a survey to find out how many households own a barbecue. Part A says the store discovers that any given household has a 40% chance to own a barbecue. If the store surveys 15 people, what is the probability that none of them own a barbecue? Correct to 4 decimal places. Alright, awesome. So this is just a 1-mark question, so we can actually do everything in our CAS. We don't have to show any working out. So what we're going to do is recognize that we have a binomial distribution question on our hands here, okay? The reason that we know that is because we've got a certain number of trials, in this case 15, we've got 15 attempts or 15 surveyed, and each one of them has a 40% chance to own a barbecue, okay? So regardless of whether someone else owns a barbecue, each one of them still has a 40% chance. So it's all independent of each other, okay? And that's a really big kind of attribute of binomial distribution. So where we go with with this is binomial Pdf. Okay, actually, yeah, we can do PDF. So that would be menu 55D for me in my CAS. I'm sure you'll be able to find it in your CAS as well. So it's going to ask us for a few things. It's going to ask us for n, p, and x. Okay, so n is our number of trials, our number of attempts, our number of surveyed people, in this case 15. P is the probability of success, okay, so the probability that they own a barbecue, which is 0.4 or 40% in this case. X is our value that we're looking for, okay, so it's asking what is the probability that none of them own a barbecue, which means that we don't want anyone to own a barbecue, so X is equal to 0. So that's saying that 0 of these 15 people own a barbecue. We literally just click enter, and what it pops out is 0.0005. That's our first and only mark. So that's it for part AI. Let's move on to part AII. So AII says, what is the probability that less than 8 of them don't own a barbecue? Okay, so there's a few, kind of almost like a double negative in here, which will make it probably a bit tricky. So part AII, it's 2 marks. It's the probability that less than 8 of them don't own a barbecue. Alright, so there's multiple ways we can do this. We can say that and I'll just take you through one way because this is probably the way that makes the most sense. So the probability of not owning a barbecue, of any given household not owning a barbecue, is 0.6, right? Because the probability to own a barbecue is 40%, so the probability to not own a barbecue is 60%. That makes sense. This is our first mark. Now, back to binomial distribution calculator. So here we're going to actually use our Binomial Cdf. All right, so Binomial Pdf, actually let's do this now. So Pdf is used when you have one value that you want to figure out. So, 0 people owning a barbecue. Cdf is when you have a range of values, for example, less than 8, right? Because then we've got a large range of values as opposed to just one. So with our binomial CDF, we're asked for a lower, upper, n, and p. So our lower bound is going to be 0, right? Because we're looking for less than 8, okay? So our lowest possible number of people owning a barbecue or not owning a barbecue is 0, right? The upper bound is 7, right? Because we've got less than 8, which the highest number that's less than 8 is 7, right? It has to be a whole number in binomial. N is the number of surveyed, which is 15, and P is 0.6, right? Because the chance of not owning a barbecue is 0.6. So we're looking for the probability that less than 8 of them don't own a barbecue. And what we come out with when we click enter on our CAS is the probability that X is less than 8 equals 0.2131. This is our final answer for part AII. It's our second mark there. Guys, if you have any questions about it, let me know. But let's move on to part B. Part B moves into statistics, and part BI is a 2-mark question. Terrible B. Alrighty, awesome. So in a larger survey of 120 people, P hat is the random variable of the distribution of sample proportions of households that own a barbecue. Awesome. And we need to find, let's change this to 120, so 120 surveyed. find the probability that p hat is less than or equal to 5 on 12. Awesome. Correct to 4 decimal places. So, as always with these kind of questions, guys, we want to grab our p hat and we want to convert that into an x value so that we can use binomial distribution with it. All right, so we know that p hat is equal to x over n, where x is our successful attempts and n is our total attempts or total surveyed or whatever it might be. So we know that our p hat is going to be equal to 5 on 12. We're looking for our x value, and we know that our n is the number of surveyed, right, which is 120 in this case. So therefore x is equal to 50, right? So therefore, the probability that p hat is less than or equal to 5 on 12 equals the probability that x is less than or equal to 50. Okay, which makes sense because if we have a proportion of people who own a barbecue that's 5 on 12, if we survey 120 people, then that means that 5 on 12 of those own a barbecue, which would be 50, right? This is our first mark. Where we go from here is our binomial CDF. So binomial CDF, in our CAS again, lower, upper, n, p. Now our lower this time is 0, right? Because we're doing everything less than or equal to 50. So from 0 to 50. So lower is 0, upper is 50 because we're including 50. N is the total number of people surveyed, which is 120. And P is our chance that they own a barbecue, which in this case is still 0.4. Plugging this into our CAS, we get an answer of 0.6810, which is our second and final mark for this question. And that's it. So the biggest thing here is converting our p hat value into an x value and using our binomial distribution. That's it, guys. Let's move on to BII. BII asks us to find a confidence interval. All right. So this is a 3-mark question. And it says 45% of households in the larger survey own a barbecue. Find the 96% confidence interval for the estimate of proportion of households in this town that own a barbecue, correct to 4 decimal places. All right, awesome. So we know that confidence interval is given by p hat minus z, p hat 1 minus p over n, p hat plus z, p hat 1 minus p hat over n. And you'll get used to this formula as you go. Now, we need these 3 things. We need p hat, z, and n, right? So p hat is our proportion of successes in this sample. So 45%, because we know that 45% own a barbecue. So that's all good. We know our n value, because that's 120. That's the amount of people in the survey or the sample. But we don't know our z value, okay? So because normally with a 95% confidence interval, our z value equals 1.96, okay? But because we've got a 96% confidence interval, we need to find this. We need to find this ourselves. Now, in your CAS, let me just check if we can do this in quite an easy way. And I don't think we can, but that's cool. So, what we want to do is, in a 95% confidence interval with this z equals 1.96, what we're actually saying is that between negative 1.96 and 1.96 z value, 95% of the data lies between it, okay? Now with this 96% confidence interval, what we're saying is, we've got this z value here and negative z. Between these two values, we have 96% of the data. That's our 96% confidence interval, right? So what we need to do is find out what this z value is. So we need to use our inverse normal, okay? Because we know our probability, but we're trying to find our z value. So if there's 96% between here, that means that there's 2% above and 2% below, right? Now with our inverse normal, we always have to take the area to the left of the point that we're looking at, right? So with this one, we know that there is 96 between here and here, and then 2% below, right? So there's 98% of the data below z. Okay, so in our inverse normal, we're going to say that our area is 0.98 because there's 98% of the data below z. Now, our mean in this case is 0. We always use 0 and standard deviation of 1 whenever we're figuring this out. What this gives us is a z value of 2.05. This is our first mark. If you have any issues with that, please let me know in the comments below. I'll be able to explain anything there. I just don't want to make this too drawn out because it is quite boring. So we'll just keep that as 2.05. As always, just let me know if you need a hand with anything. So now that we know our Z value, we can actually sub in our values. So we know that our P hat is our 45% because we know that that's the proportion of people who own a barbecue. So we can say 0.45 minus our Z value, in this case is 2.05, times 0.45 outside of 1, take 0.45 over 120. And our upper bound will be the same, but just plus. So 0.45 plus 2.05 outside of 0.45, 1 minus 0.45 over 120. Cool. And what this gives us, that's actually our second mark, so plugging in everything there gives us our second. And our third mark is actually stating what the confidence interval is. So 0.4458, 0.4542. And that's it. That's our third and final mark for this question, guys. I know confidence intervals are irritating, but it's just part of the study design now, and you've got to deal with it. So that's it. Let's move on to part C. Part C is kind of along the same vein with confidence intervals. I shouldn't have rubbed that out. That's all right. Let's get rid of this. And also let's get rid of this. So, part C is a 3-mark question again. So, 3 marks. And we're saying the store conducts a different survey to find out the proportion of households in the town that own a fire pit. After conducting the survey, they are 8% certain that between 10% and 20%, sorry, 18% own a fire pit. If 200 people are surveyed, find the value of A corrected 1 decimal place. Awesome. So we're still dealing with confidence intervals, right? Because we're 8% confident or 8% certain, and our confidence interval is between 10 and 18%. So our confidence interval is 10% to 18%, which is 0.1, 0.18. Awesome. Now, confidence intervals, as always, are given by P hat minus Z, P hat 1 minus P hat over N, P hat plus Z, root P hat 1 minus P hat over N. Awesome. So these two correspond together. So this 0.10 is our lower, this 0.18 is our upper. And now what we can do is actually equate these, because what we're trying to figure out is the percentage confidence level, right? And that's given by our Z value. So whatever this Z value is, that's going to determine what our percentage confidence is. So we're going to need to find this Z value. So now we can actually equate these lower and upper bounds. We can do either one. I'm just going to go with the lower because I just choose to do that. So that means that our lower bound, 0.10, is equal to this. So P hat minus Z side of P hat 1 minus P hat over N. Now, we know that our P hat is always halfway between our confidence interval, all right? So lies directly in the middle. So between 10% and 18% is 14%. So P hat is 0.14. We don't know our Z value, that's what we're searching for. Again, 0.14, 1 minus 0.14. And our N value is the total number surveyed, which is 200. And that is equal to 0.10. Awesome. This is our first mark. Now, I would show as much working as you can here because it is a 3-mark question. So just moving down the chain, we get 0.10 equals 0.14 minus Z times the square root of 0.0006, which equals 0.14 minus 0.10, and I'm just moving this Z across, and we get 0.0245Z. And then from there we get Z equals Z equals 1.63. This is our second mark. So now we can actually use this to figure out our confidence level, I should say. So what this means is, on a normal distribution graph, we have our mean of 0, and we're 1.63 standard deviations away from the mean on either side. Okay, and what we're going to have is a certain number of data that lies between these two values. So we take our positive Z and our negative Z, and we find the area between those two, and that is our level of confidence. All right. So the way we do that is by using our normal CDF. So it's going to ask us for lower, upper, mean, and standard deviation. Cool. So our lower is negative 1.63, upper is 1.63, our mean is always 0 when we're doing this, and our standard deviation is always 1. Okay. Now, what that spits out is 0.8970, which means that we are 89.7% certain, because this in a percentage form is 89.7. So therefore, A equals 89.7. And that's our third and final mark for this question. Guys, that actually wraps up MM401. If you have any questions about it at all, please let me know in the comments below. But otherwise, as always, thank you for watching, and I'll see you in the next video.